So for this example, we're asked to sketch the following question. Um, so in your analysis, we want to provide the following information if it exists, and we're going to start with part A, and we're asked for the roots, the domain, the intervals for which we're positive, and the intervals for which we're negative. This question looks a lot like our quiz 3, right? So what we're going to do is we're going to take f of x, and the first thing that I'm going to do is I'm going to factor this expression to make it nicer to analyze for the roots as well as intervals of increasing and decreasing. When I do this, I get x to the 1/2 4 x squared minus 5. And here, difference of squares. So this gives me x to the, and I'm going to write it as square root x bracket 2x minus root 5, 2x plus root 5. And here we can see we have a square root here. So before I even talk about my roots, I'm just going to say, okay, I have a square root. This gives me a domain restriction. So I'm going to talk about the domain. And here, the square root x implies that x has to be greater than or equal to 0. I'm not dividing anywhere else. I'm not taking the square roots of a variable x anywhere else. I'm taking square roots of 5, which is fine, and I'm not taking the lns. So this gives me my domain is x are the real numbers such that x is greater than or equal to 0. You could also say x is an element. Oh, let me put that up a little bit. You could also say that x is an element of 0 to 1. Right? So now that we have our domain, this factored expression can tell us something about our roots. We look at our roots. We've got that root x equals 0, which implies x equals 0. We've got 2x minus root 5 equals 0, which implies x equals root 5 all over 2. And we've got 2x plus root 5 equals 0, which implies x equals minus root 5 over 2. But this is not allowed, not a root, as it is outside the domain. So because it's outside of our domain, our roots are x equaling 0 and root 5 all over 2. Okay, so that gives us our roots, and now intervals for increasing and decreasing. To do this, we create a sign chart. So I'm going to create a sign chart with my values minus root 5 all over 2, 0, and root 5 all over 2. I get 2x plus root 5, 2x minus root 5, root x here, plus, 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 negative, plus, negative, negative, negative. I am a 0 here, 0 here, plus, plus. I'm not defined here, so I'm not defined here. I'm a 0 here. I'm negative here. I'm a 0 here, and I'm positive here. So the intervals for which the function is positive, that's going to be here. So this is x is an element of, or the interval is root 5 all over 2 to infinity. And this interval is going to be here, which is 0 to root 5 over 2. So now we've got our part A complete. So now we go on to part B, which is asking us to determine the critical points, vertical and horizontal tangents, local max and local min, intervals for which the function is increasing, intervals for which the function is decreasing. So all of this analysis is we're going to be looking at f prime of x. So to compute what the derivative of x is, a lot of people will try to go from the rational form. They'll try to go from this factored form and try to take its derivative. Don't do that. Just go back to the nice version. Take this polynomial and take its derivative. So we've got f of x equals 4x. We've got 4x to the 5 over 2 minus 5x to the 1 over 2. So this derivative gives us 20 over 2 minus 5 over, let me actually write our variables. So it's 20x to the 3 halves minus 5 over 2x to the minus 1 half. And now that we have our derivative, now we factor it. And what we need to do is create a rational function. A lot of people try to factor this without creating a rational function. That means they don't quite get the right 0 and they don't quite get the right roots. It's easiest if we just factor it. So 5 over 2. Okay, and then we're going to get 4x to the 3 over 2 minus x to the minus 1 over 2. And here we want to factor some more. So 5 over 2. We're going to factor out this 1 half to give us 4x squared minus 1 all over x to the 1 half. And here we get 5 over 2. And this 4x squared minus 1 is going to factor to give us 2x minus 1. And let me make that a little bit cleaner. So we're going to get 2x minus 1, 2x plus 1, all over x to the 1 half. And now we've got for our critical values, we're looking at the roots of the numerator and our denominator. And then we've got our numerator and our denominator. Here, the numerator gives us 2x minus 1 equals 0, which implies x equals 1 half. And 2x plus 1 equals 0, which implies x equals minus 1 half. But this is not allowed as minus 1 half is not in the domain. So we just have this value here. In the denominator, we have x to the 1 half equaling 0, implies x equals 0. So taking this, we have our critical points. Our critical points are going to be 1/2 f of 1/2 and 0 f of 0. Now for our vertical tangents and vertical and horizontal tangents, our horizontal tangents come from the numerator, so it's going to be only the point 1/2 f. So let me just, we have a horizontal tangent at 1/2 f of 1/2. And we have a vertical tangent, which comes from the roots of the denominator that's inside our domain. And this is going to be at 0 f. So now we're looking at our local maximum and minimum, intervals of increasing and intervals of decreasing. And to do this, we look at a sign chart. So we're going to create our sign chart about our values, -1/2, 0, 1/2, 5/2, 2x minus 1, 2x plus 1, and square root x. And note that I do the entire domain, even though I know there's a domain restriction, because what I'm going to do is within this analysis, I'm going to input my domain restriction. So here, plus, negative, 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 plus, 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 negative, and then plus, plus. Here, I'm undefined here. So undefined, 0, undefined, but I'm not defined here, here, or here. And I'm negative here, positive here, 0 here. So this means I'm decreasing here and increasing here. I like drawing these arrows after I get these signs. So when I draw those arrows, that lets me easily determine what the increasing and decreasing is here. So what I'm going to do is just note what my intervals of increasing and decreasing are. So I'm increasing here from 1/2 to infinity, and I'm decreasing from 0 to 1/2. And then for this, I'm just going to comment what this is down here. So there is a local minimum at x equals 1/2 as f of x is decreasing right before, I guess I should say just before just before and increasing just after. And this is the first derivative test. Now we have our part B done. So now we're going to move on to